You didn't see the flyer.
Yeah, meaning. Great. Pretty good. How about you?
You will?
And then you are going to also say some words and to welcome them, and then you can start
Okay.
telling them to talk about their personal experience. One by
Okay.
one. Okay. Good afternoon, everybody. Yeah, we are very happy to have all of you here to join our career panel discussion on Pi Day event. This is a for students by student event, and this is a new event, very different from before. We have very honored to have 6 wonderful young men and women, ladies and gentlemen, to come here to share their experience with all of us, to inspire our students, and even including me, for what they have done and through their many years. So now we are going to start our event, and this is my colleague, Paul Wilkinson. He's a computer science professor. I'm Yu-Chan Chen, a math professor here. Now let's give a round of applause for all our speakers.
Good afternoon, everybody. Let's see. Let's pretend this is a presidential debate, okay? Meaning everybody's going to get to say something, and then you guys get to, as far as give questions, and let's see how it turns out. Now, I'm going to start at the far end of the table and then work my way back over here, if that's okay with everybody. Yes? No? You don't care?
Ladies first.
Okay, go ahead and start. And the first thing is to introduce yourself and tell us something about you.
Okay. My name is Danielle Holzberger. I'm currently a software developer at NASA Jet Propulsion Laboratory. I just completed my bachelor's in computer science at Cal Poly Pomona. But prior to that, I'm actually from New York, and I attended community college for the first 2 years of my bachelor's, and I actually majored in computer science and mathematics. And I also tutored all levels of mathematics while I was completing my 2 associate's degrees. And I really enjoyed tutoring mathematics during that time, and I really wanted to keep going with math once I transferred. Unfortunately, the logistics of transferring made that a little bit more difficult to do, but that's why I always love to reach out and talk more about mathematics with students, in addition to computer science, because both of those are very important in this day and age, especially with how fast technology is moving.
Emily?
Cool.
Hi, my name is Emily Liu. I grew up around here in Arcadia and went to PCC between 2013 and 2014. Took a bunch of classes with Professor Wilkinson and all the other computer science professors. And I also finished off my math here too in MathPath, if anyone is doing that. It's a great program. So after PCC, I transferred to USC, where I graduated with a bachelor's in computer science. During that time, I also interned at Amazon Web Services in the relational databases team. And afterwards, I graduated and started working as a software engineer at Microsoft in a team called Strategy and Ecosystem, who are engineers who work with our company partners, companies like Apple, HP, Lenovo, like the people who actually make the physical computers that you use. We worked with them on the intersection between that and the operating system. And I actually just left Microsoft at the end of last month. I'm taking a month off, and I'll be starting at a new company called Qualtrics in April.
Sir?
Hello, everyone. My name is Edward. I'm a graduate student now at Cal State LA. I'm doing electrical engineering, but I was at PCC for 7 years. My time here was very interesting because I had to explore, and I decided to be an engineer kind of late in the game, but I came here as an art major. and now I'm working also at NASA JPL. And I'm a first-generation college student, and if you guys have any questions, you guys can talk to me about how that experience was after. But yeah, I was a math tutor here as well, and I think that PCC was a really good place for me because it allowed me to explore and to meet a lot of good professors here that encouraged me and inspired me. And I don't think without that I would be here where I'm at today. Thank you.
Hello, my name is Dave Smith. I came to PCC in 2010 as a student, and PCC hasn't let me go yet. I started off as a student, then I became a tutor, a math tutor, like a lot of the other people here. From being a tutor, I was asked to start working on the PCC website, and I started doing that while still taking classes here. Then I became a college assistant. Then I became a full-time web developer, and now I am currently the lead programmer analyst for the college. And I've been doing that for about a year now. My background, kind of like Edward, I came here as a music major. I had no intentions. All I wanted to do was be a rock star. And as soon as I took my first class, my professor actually convinced me that music wasn't what I wanted to study here. I don't think he intended to do that, but that's what happened. And I'm actually happy about that because I did have a passion for music, and I thought that was my only passion for my entire life. I thought that I was only allowed to have one passion, and I realized that I actually had a bigger passion, and that was computer science. I came here when he told me that music wasn't for me. I immediately went to computer science, and I didn't touch an instrument for the next 7 years, and I regret that, but you just never know. That's my story. Thanks.
Hey, my name is Adam Marks. I am a software engineer and a student of mathematics, a lifelong student. I've been a software engineer out in the industry for 20 plus years. I did a bachelor's degree in mathematics at University of Michigan, which is where I'm from. I took a couple of computer science classes during that time. I took a 1-credit C programming class. And then I think my first year, I don't even think I knew what I was doing, but it was a Fortran programming class. And we were using some old Unix hard terminals and using the VI editor on a hard terminal. And many years later, I was using virtual versions of those, and then I realized what I had been using. So I started grad school back in '95, and then I dropped out right away because I wasn't sure that I wanted to stay in academia. Luckily for me, I had some software skills on the side. I had taught myself how to program. My dad and my older brother had both kind of taught themselves some basics. Including the language BASIC, which was popular in the 80s. So when I dropped out of grad school, I had a couple of friends who had started consulting jobs where they were doing programming, and I saw that they could do it. One of my friends, he didn't go to college. The other one, he had done his bachelor's in mathematics like I had. So I knew it was possible, and I got a job doing that. And then the dot-com boom happened. This is mid-1995, and I got hired over the phone to work in San Francisco at the online portion of Wired magazine. This is when there were very few commercial websites on the internet, so it was a wild days. We were running our web servers on Silicon Graphics servers because those were the best machines you could get at the time. I was working on the reporting systems. So the system that I inherited, every night this giant Perl script would run, pull all the web server logs down, parse them, load them into the database, and then the business people upstairs could run reports and figure out who to sell ads to. nowadays you can just buy this type of software off the shelf and it's no big deal, but for us back then, this was all had been dreamed up and figured out internally, and it was super buggy. So 3 nights out of 7, I would come into work and the thing had died in the middle of the night, and then I would have to like pick up the pieces and try to get it to finish. So I learned a lot. Super fun times, very exciting, very relaxed and invigorating atmosphere. This was in South of Market in San Francisco. That led me to some other startups. I worked in security for a while on email systems. I actually tried to switch into working on music software, but I didn't get the job. But on the side, I was teaching myself digital audio related programming and graphics programming, even though I couldn't get a job doing it. Later on, that led me to a company that I co-founded back in 2011. I had just taken a graph theory course at Cal State LA with Dr. Liu here. That really changed the way I think. I was a big fan of mathematics, but once I saw graph theory, like once you get comfortable with graphs, it's hard to not see them everywhere, especially when you're programming. And so when I started working on that company, and I started using graphs to architect the system that we were building, and to this day, that system remains like that, using those core ideas. So that was a venture-backed startup that I started with 4 other colleagues of mine. We worked on that for about 5 years, and then eventually we were very fortunate in that right before we ran out of money of our venture capital, we were acquired by Amazon. And so we all went to work for Amazon Web Services, and we took the product that we had created, which was called Biba, and we relaunched it as Amazon Chime. Which today is one of the many AWS services that is publicly available. So Amazon Chime is a communications platform for work with chat and audio calling, screen sharing, video calling. I left Amazon back in October, even though some of my best friends still work there, and I loved working there the entire time, but I decided that it was time for me to go back to finish my studies in mathematics. So I quit in October and have done a whole bunch of preparation, and I'm starting a PhD program in mathematics this fall. And I'm really interested in the intersection of mathematics and software engineering, theory of computation, and things like this. Thanks.
Okay, I think I'm the only person not in a computer science major or engineering here, but I feel like I still fit in this platform is because in my research, oh, by the way, I'm a second-year PhD student in chemical biology, yes. So my research is to use the mathematical algorithm to study the physical property in biological system to understand some chemical phenomena. So what I'm studying is incorporate STEM majors together. Let me repeat again. I use mathematical algorithm to study physics property in biological systems to understand some chemical phenomena. So that's why I'm here. So so a little bit about me. I came to the U.S. back in 2005 with my high school degree from my country, and I took it 1 year off because by the time there's I know that there's still a policy here. If you are not California residents, you probably have to pay out-of-state tuition. So I took that year off and spent most of my time in an English learning center and to kind of improve my English. And then in 2007, I enrolled in Pasadena City College. Well, 2007, it's been like 10 years already. Yeah, so, and I spent 3 years in Pasadena City College to study biochemistry, because by the time I thought that, pharmacy is a good job and make a lot of money. So I said maybe biochemistry major is one of the path major, or quick major for me to get involved at a pharmaceutical or pharmacy school. So I spent 3 years in here to study chemistry, biology, and physics, and of course math. But by the time math is not my major, is because I thought that, oh, I think I know how to count, that's good enough, right? If you know how to count the pills, that's good enough as a pharmacist. So you don't have to be really good at math unless you are don't know how to count money or something. So I took the math placement test, and I was able to enroll for Math 9, that was pre-calculus. I thought I can do better, but take a bath and think that, I don't have to have the exam the level that high to like 5A, the calculus, because I do have to learn some mathematical terms. So I did something trick. I marked some question wrong because I don't want to take that high level, start 5A's. So I purposely make my placement test grade a little bit lower. So I enrolled Math 9 pre-calculus. And then I took the math sequence from calculus 9, Math 9, 5A, 5B, and 5C. And now, by the time I said, I think that should be good enough because linear algebra and differential equations is not going to apply in my biochemistry major. And it's really hard for me, to be honest. I'm not a mathematician by the time. So I said, okay, that is good enough. Okay, so I stopped at 5C, and luckily I was able to transfer after 3 years with my GPA. That's good enough for me to transfer to UCLA. So I start my junior year in UCLA as a biochemistry major, and I graduate after 2 years. And by the time I was studying in UCLA, I thought, UCLA, top 10 or top 100 school in the world. So I think I'm okay with that. So I just pushed myself to graduate by the time. Even though I did not pay attention or did not put much effort in UCLA, I still tried to put a little bit, make myself a little bit think to the way that, okay, GPA is still important if I need to do some change. So even though I'm not work hard at UCLA, I still try to stay as with a good GPA by the time. So my GPA was not that high, but not that bad at the time. And I started to work in a chemistry or analytical company in Southern California. And my start salary was $10, like 10 years ago, $10. That was a little bit higher than the minimum wage, right? But as a bachelor degree holder from UCLA, you expect that it should be higher than that, right? But it's not. So I spent 2 years in that company to strengthen my analytical skill, because I know that experience is one of the important things that you would need in your future career, even though degree is one of the important things, but experience also, especially in chemistry field. So I stayed in that company for 2 years and tried to learn as much as possible. And in 2012, I switched to another company and my income doubled. So that was a little bit improvement in my income. And so I stayed in the second company and worked as a senior analytical chemist. And I think my career is just like that. Okay, maybe just stay at the company and get a little bit higher and higher salary increased. And my supervisor was a master's degree holder, and he got, for some reason I knew that his pay is a little bit higher than me, and then I thought that, if I can have a higher degree, probably my salary would be raised a little bit. So I quit that job and apply a master program, by the time I thought that I just need a degree to get more salary. That's what I thought in my mind. So I joined a master program in Cal State LA and stayed there for 2 years to do the research. So, and follow my previous principal investigator who inspired me, because during the meeting conversations that every time I have to report to him, say, oh, professor, what have done the past week? What have I found in my research? Do you think that's good enough to publish a paper? And then, so during the conversations, what he thought inspired me, and I also inspired him, because what he thought is, oh, the students had a lot of critical thinking, and not only because he knows what he's doing, but also he had a new idea every time we had a discussion. So one day he said, hey, Kingsley, after graduate with a master's degree, do you think that you probably can get a higher one? How about apply a PhD degree? I said, oh, again? School again? No, I don't want to go back to school. I just want to get money, right? And then, but I said, but degree is just, it's not one of the important things, but it's something stuck in my mind. As like Chinese people, we all think, oh, high degree, more money. That's equivalent. Okay, so I told myself, why don't you try and apply a PhD? Who knows? So I got if I remember correctly, I got 5 offers, but 4 of them were in East Coast, and only one in Riverside. And I said, oh, Riverside is not as good as my bachelor degree school, but PhD degree is a little bit different, because it depends on how you do the research. It not depends like if it's a frame or not frame. So I accept the offer and study in UC Riverside, and I thought that chemistry is going to be one of my, not, actually I should say chemistry major is going to be my future career. Because in the first year, we have to do the lab rotation to see if you can fit physical chemistry, analytical chemistry, organic chemistry, or inorganic chemistry. And finally, I settled down in physical chemistry. And my current principal investigator, who is very good at computational modeling, and what we're doing is to model the biological system and to study how it reacts in human body. So we're doing drug development, but not in a wet lab. We used dry lab, which is what we call the computational lab. So in our lab, we don't have any chemical, even though I'm a chemistry major. That's a little bit tricky when I talk to my colleague, what are you doing? I say, oh, computer. But wait, you're a chemistry major, but you're doing computer? I said, yes. We calculate the energy and like the binding activity, etc., and study the drug developments. So we do have a lab and then use computer to study that. So with that being said, I probably would like to show you some of my slides to see how I fit in today's event. Okay, so and if I have time, I will.
Yeah, you've got a few minutes. Let me.
He said he was going to do it after. I thought he said he was going to do it after. Okay.
So for the talk, the unreasonable effectiveness of mathematics and chemistry. So, so what I'm start with is the motivations why I would like to study that, because we all know that in biological systems, they are composed of molecules in a complicated structure. And many experiments can provide only macroscopic phenomenon, such as the advanced X-ray crystallography and MMR and STEM techniques. They all can provide structures and atomic details, but lack of dynamic, just like I showed you here. We have this TEM figures to analyze the amyloid beta peptide polymorphisms, but we don't know how this is developed. This is current project I'm working on with another professor from Cal State LA. And so what is the computational modeling? It's a way to approximate the structure and behavior of complex system using mathematical descriptions and computer simulations. So we have two approaches. One is a classical one, and one is quantum one. For my field, I'm doing a classical one because it's more easier. And so from that, we have to solve the equations. See, there's math here. I'm here because it has math. So we're gonna calculate the energy in terms of the bond angles, torsion angles, and non-bond pairs and partial charges. And then there's another branch, we call it quantum approaches. It's out of my field, but I do take that class. Pretty much it's to solve the Schrödinger equations, but I'm not gonna lead you to there yet. Maybe we can talk about this later on. So a little bit things I would like to appreciate as. In 2013, we have 3 Nobel Prize laureates who are an expert in molecular modeling, and then people give their credits because they used computational model to study the biological system. So, yay, our field is indeed shade lines on research field. And so, like I said, we treat each atoms with the sphere, and there's parameters associated with that. So what we need to do is to combine these terms and calculate it using computers. And then by solving this potential energy force field, we'll be able to see the phenomenon in biological system. And yes, and by solving the Newton's second law, we will be able to generate a trajectory with force field and with a movie. And of course, with this molecular dynamic simulations model, we're gonna use what we call Violet algorithm. The simulations showed how atoms move with time, and it's gonna be, or typically in a nanosecond time scale. Just like when we see the phenomenon in the biology system, it can be like days or times, but our computational take very quick, like nanosecond time scale. So in chemistry, that you can see in math. So this is the model I'm modeling, and then we are doing a protein engineering where you see this ligands interacting in the pockets of the biological systems. By the time see the ligands flows away, and then we'll see how this ligand can interact in our human body or in the enzyme or in proteins, so we can see the structure and to see the functions in the ligands and with the ligands in the protein system. So this is what we're research for. So our research focuses on the biological system and the study, and hopefully we can see the drug property. And so, because we know that to survive, molecules in cell need to find their partners to bind, and it may bind between protein, or protein and chemicals. So all the protein functions, molecular bindings, they are governed by the basic chemistry and physics. So that's why we use the computational tool to study the molecules. And then I'm not gonna talk more than just show you some equations. That's how we study the energy, the binding free energy, by predict how the drug is binding tightly, or how tight the drug is bind to the molecules. By solving these equations, we'll be able to find this binding free energy. And then we all know that from statistical mechanics, lowest energy, meaning it's more stable, and it's what we're looking for. So by solving those equations, we'll be able to find how tight the molecules to the protein. So this is current project, or yeah, my colleagues doing, and we are predicting some drugs candidates, and then provide the suggestions to a pharmaceutical company to have them synthesize some drugs. So with that, I would like to take any questions and any research.
Thank you. That was a good save there because my master's is from UCR in modeling and simulation.
Yeah.
Mathematical modeling and simulation. But then, of course, I got it back in the dark ages. Okay, now, I've got a series of questions, but to start off with, here's an interesting little tidbit. There are several individuals here that said they wanted to start off in music. Well, according to a friend of mine that's a neurologist, music and mathematics are processed on the same side of the brain in the exact same area. Now,
Nice.
any thoughts on that? Why that may be?
You got your time signatures. The time signatures, right? You got like four fours? Or?
Yeah, it's the time, and as far as musical score is really a sequence of numbers. Which is processed on the same side of the brain as what we got mathematical thought or equation is, because it's just a different sequence. Now, knowing that, let's see if anybody here besides me is old enough to remember this. There was one TV show that all of its music was done by a computer, both scored and played.
Jeopardy?
Sorry, I'm a science major. I don't know anything about music.
Any thoughts?
Give us a hint.
Give us a hint.
Give us a hint.
What year was it?
What year was it?
Yeah.
Let's see, late 80s?
Not Doogie Howser.
Huh?
Doogie Howser?
No.
Oh, it sounds like a computer.
Well, was it Whiz Kids?
I wasn't born yet. Nah.
Whiz Kids.
No, I'll give you a hint. Cheech Marin.
He had a TV show?
Yep.
Well,
Give you another hint. Don Johnson. Miami Vice.
That was odd. That was written by a computer.
That was written and played solely by a computer.
wow.
Yeah, and one person. Now, I have another little thing.
Trivia?
Today is Pi Day, right? Yes, no? Kind of, right? Yeah. I wouldn't have a free shirt otherwise, right? No. Now, is the meaning of life encoded in pi?
3.1415.
3.159.
No, the meaning of life, is it encoded in pi?
Yeah.
Okay,
Sure.
Emily, why?
There's got to be a 64 in there somewhere.
There got to be a what?
A 64?
That's not the meaning of life.
Why is the meaning of life 64?
Nobody here? Okay, nobody has read The Hitchhiker's Guide to the Galaxy. Great.
Oh my God, 42. I meant 42.
And 42 appears an infinite number of times within pi, so therefore the meaning of life is in pi. Correct? Oh, you guys. Oh. Guess I'm from a different generation. Oh well. Okay, now let's see. What got you into the line of work you are in today?
Oh, okay. I guess I'm going first. Well, when I first started at JPL, I knew that I wanted to be a software developer. It was just a matter of figuring out what area I wanted to be in. And so when I started at JPL, I was an intern in flight software for the NISAR mission, which is a collaborative mission between NASA and the Indian Space Research Organization to create an Earth-orbiting satellite that has radar that's capable of detecting shifts in plate tectonic shifts as small as the width of a tip of the pencil. So it's very, very accurate. And so I started, that was embedded development. And while it was cool that I got to work with hardware, I actually got to go into a clean room, and we had to wear like the little booties and a hairnet. And as fun as that was, I didn't get to enjoy math as much while working on that. And so at the time, I was integrating a mathematical software into the flight software that allowed it to basically estimate its current position and velocity during its orbit. And the person I was working with actually introduced me to his team, and that's how I ended up in mission design and navigation, where pretty much 90% of everything that's done there is math. We pretty much use partial derivatives to compute trajectories and perform mission operations, such as entry, descent landings, like the InSight landing that just happened a few months ago. And so my main drive, though, and what I kept telling people was, I just want to be able to program and do math at the same time. And so that's how I ended up where I am now.
Yeah, so similar to some other people on this panel, I didn't know that I was going to be going into STEM until pretty late. I actually went into college as a pre-law and art history major, because I didn't think that I was a STEM-y kind of person. And I think a lot of, especially women, might relate to that in their early lives. And then I decided that pre-law wasn't really for me, and I came to PCC, and I started taking calculus classes, and actually just found out that I really loved calculus. And afterwards, my dad was a computer programmer, so he encouraged me to take a computer programming class. And I was actually late in the game, so if I had to take all the classes in order, I would have missed my transfer deadline. And so I think I came into one of the computer science classes and asked them, like, what if I just finished all the coursework for 2A now and then did 2B? And I'm sure they said yes, thinking that I would, not do it. But actually, the first weekend, I took the coursework for 2A, and I just did the whole thing. And it was so much fun. Like, programming is really fun. You're just following, like, a piece of data around, making it do what you want to do. It makes sense. When it works, it works. When it doesn't, you can figure it out. And it's just solving a problem and making a solution to a real-world problem. And so I thought that this is for me, and kind of just went on from there. And the good thing about PCC, especially in community colleges, is that they give you the flexibility to try these new things and to pursue them. Like, if I had stayed at a UC in the major in the school that I was in, I would never have been able to transfer into the engineering school because of how impacted it is. I'm sure you guys are familiar with that. And so, use this time that you have now to explore a lot of different things. You never know what you might end up falling in love with.
So for me, it's been a quite interesting journey, I would say. Again, like I mentioned earlier, I came to PCC as an art major, and I came out as an electrical engineering major. So that transition is not done overnight. It's done over the years and hard work. And if I think back in hindsight, like thinking back to high school, I really didn't know what to do. I was growing up in East LA. There's a lot of other things that happened in that area. So for me, college was something that was like foreign to me. So no one in my family went to school. So for me, it was like, I don't know, I didn't think I was going to go to college. But I came here as an art major because I knew that it was something that I liked to do. And also, like, I'm pretty sure you guys know the label or the brand Obey. Shepard Fairey came here, and that was like one of the main reasons why I came here. So when I came here, I was like doing a lot of screen printing and stuff like that. I was also skateboarding, so that was like, kind of like rebel kid back in the day. But yeah, then I had some life experiences, and I started PCC in 2008, and then my mom was just like telling me to go to school and to do something. She's actually in the audience here, but everything I do is for her. But yeah, I came here, and then I took some math classes, and I had a math professor that was really good, tell me that I had potential, and I think to me that was really instrumental to my development. Then I took some introduction to engineering courses, and from then on, it was just like love at first sight. But But I mean, it was not easy. You know, I failed many classes. I started in math 125, or 402 actually, and I went all the way up to math 55. So in total, I took 10 math classes here. I failed, you know, algebra twice, failed trigonometry once with Professor, she's in the audience as well, and then I also failed calculus. But you see, I kept going, and I had that perseverance. And I think that's something that you need to pick up as well, because there'll be times when it gets hard, and you know, you have to just adjust, and you have to work hard, and you have to dig deep into your soul and realize what is it that you really want. Thinking back to how I got into JPL, that was not easy as well. I got rejected the first time, which really hurt me as well. But then I reapplied like the year after, but this time around I had more research experience, and I joined the research program at my university, Cal State LA, and I got to work with someone at JPL, and that was also really nice. I did optics, which is something that I didn't really know about. And then I was merging like electrical engineering and optics, and I really just fell in love with that. And then I applied for a fellowship. I got picked up at Caltech. I was there for the summer working at JPL. And then I was asked to stay, and I've been there ever since. And I've been there for the past 2 years, working on my master's thesis there on the project. And I want to continue it with the PhD program and hopefully go to Caltech and, you know, maybe come back to PCC and be professor, inspire the next generation.
As I mentioned before, I was a music major when I came here, and I kind of told you what kind of took me off of music. My professor, he convinced me without knowing. And the reason why I immediately went to computer science is because while I was a musician, I came up with this really, really great money-making idea. I decided I needed to have a music competition online. And with my brilliant musician mind, I didn't realize that actually takes money to like hire programmers to like program a website. And I had zero money in my account, so I said, hey, I'm gonna do this myself. And what I needed really was just a basic web page that had a button for you to upload a file and submit it on the server. And I had no idea how to even approach that. So I went to a bunch of websites, and I started looking at websites that had a little button that you click. And I started looking at the code, had no idea what the code did. So I Googled the code to see what the code did. And I would say probably, let's skip about 3 or 4 weeks later, I had a button on my webpage that uploaded a file to a server. I know now that I can actually do that in about 3 minutes, but it took me about 4 weeks, and I was really proud of myself. So as soon as my professor told me I needed to change my profession, I was like, computer science, because I really loved that experience. And so that was my main motivation. But I'm gonna be 100% honest. When I came to PCC, I came here as a scapegoat. I was like, I need something to do because my family is looking at me like a loser because I'm not doing anything with my life. I need to just go to school for a second so they can shut up, leave me alone, and then I'm gonna get my $1 million idea, whatever it is, because I don't need to say that website didn't actually work out. And I didn't think I was gonna do it. I really came here just for temporarily, and I was gonna find another way to slack off. But PCC didn't allow that. PCC said, nope, you're here. And like I said, they trapped me here, I can't leave, but they said you're here, and I had so many people who worked with me, and it actually made me love. And actually, I have to say, that lady right there is one of the biggest ones, one of the biggest ones. She's the one who I tested in Hogue, Professor Hogue. I tested into pre-algebra. So can you imagine in music, maybe that's fine, but for computer science, that means, I'm gonna be here for 10 years at least. And somehow I found out about the Math Path program, and I took Professor Hogue's class, and I decided that I'm not gonna have any other professor because she helped me actually not only understand math, but actually love math. And not only math, she actually helped me love education as a whole. And that's when I realized that I am not leaving this school. I'm not gonna drop out of school. I'm gonna just do whatever it takes. And And you know, I eventually moved on and transferred over to another college, but I still never left Pasadena. Pasadena City College never left me because if you ask me what school I went to or what's my school, I'm a Lancer for life, you know. So, you know, I went to Georgia Tech for my master's. I went to Cal Poly for my undergrads, but nothing beats Pasadena City College. That's all I gotta say.
So what was the question? How did I get started? How did I get started?
Actually, I forgot too. So, what you got in? What got you into the line of work you are in today?
Okay, this is a great segue. So first of all, in 1936, no joke, a young graduate student, a mathematician named Alan Turing, he wrote a math paper. In that paper, the main goal of the paper was to address an open problem in mathematics that had been posed 5 years earlier by David Hilbert. But in answering that question, this young guy named Alan Turing, he invented this mathematical model of computation, where he basically said, okay, what is it that a mathematician or an engineer is doing when they're trying to solve a problem, when they're doing a calculation? They're like reading numbers, writing numbers. He made a mathematical model of that, and that is what led to the creation of computer science, essentially. And so all of the computers that we use today, they really look like what we now call Turing machines. So that's the shirt that I'm wearing. This is the front page of Alan's paper. So that's how I got here. You know, other than that, I think almost all of the jobs that I've had over the last 20 years came about because of a personal connection that I had with somebody. And the same is true like in all the hiring that I've done working for Amazon or the companies before that. The first thing that we do if we need to hire somebody is to look in the people that we know and like, oh yeah, that guy Dave I used to work with, he was awesome. Let's see if we can get Dave in here. That really works. So making those personal connections when you can is super important, especially in college. You know, your professors and the other people around are people that have been out there, they've been at it longer, and so you can ask them how to do it. That said, when I was an undergrad, I did not know how to do that, and I did not take advantage of any of that stuff. I didn't learn that until much later. So, you know, the last big adventure that I was on, co-founding the startup, where myself and 4 other people, you know, we did the Silicon Valley thing. We raised venture capital money. How that happened was because I had worked with all of those people at previous companies. And so when I started to hear that a couple of guys were freeing up and they were trying to figure out what they were going to do next, I was in a similar position. And so when they were deciding to do a startup, I said, yeah, yeah, of course, I'm in, you know. And I believed in the product. Like, we had a vision. We thought we could. We started with the vision of fixing conference calling because we couldn't believe that most companies were still having this experience where you dial into a conference call with all these numbers, dial in a random huge string of numbers, maybe on your phone, and you're driving, you can't even get it in, and then you get on, you can't hear, and who said that? Who's there? What happened? Like, we set out to fix all of that, and in my opinion, we did. So, thanks.
Sir.
Yeah. So, what got me to in the line where I'm at? After graduates from UCLA, like I said, I work as an analytical chemist in a company. I think the first thing I would say is experience, because the more experience you have, the more ideas you may have, and then more techniques that you may gain from other people. So that's why I got the second jobs, because I earned a lot from the previous job. So experience is one thing. Don't just stay in a school, like for those like very straight A students, they from high school and then Ivy League, and then, you know. So that's a traditional way. A lot of people thought that is maybe the traditional way, but I think like the daughter of President Obama, she took 1 year off just to do a self-exploration. So even though she accepted in Harvard, I think, after she graduated from high school, right? So you do have to have some experience in your life, especially if you still exploring what are you going to do in the future. So the first thing is experience, and then enter to my second job. I saw that my supervisor had such a high income, like with master's degree. So the second thing I would think is motivations. If he can do it, why don't you cannot? Or why don't you, right? So probably you get some motivations by seeing other successful people, and then you will see, okay, if you can do it, maybe I can do it. And if I have time, why not? So the second thing I would say is the self-motivations. And after enroll in Cal State LA for master program, I think the third thing is explorations. Because when I was there, I inspired by my PI, and I also inspire him. So that's something I think you have to have a good leaders, a mentor, and we'll see to see if you can have more critical thinkings and inspire by a lot of people or inspire a lot of people. So exploration is also one of the things that made me got into my life where I am right now. So yeah, that's the three things I would say. It's
okay. Now for a little bit of trivia. Again, this is like a presidential debate. I'm going to throw things at you and see if it sticks. Okay. There was a fictitious planetary system in one of the most famous TV series called the Altair system. What physical device is also named, or was named that? Okay.
Next question.
How many of you say that you programmed?
Talking
Raise it
the
up.
Altair computer?
Yeah, the Altair computer
Altair computer,
was
yeah.
named after a fictitious planet from the original Star Trek.
Wasn't it a kit?
Huh?
Wasn't it a kit?
Yeah, it was
It was
a
a
kit.
kit computer that you could buy, yeah.
And now let's see about this one. What do you think has helped to get you where you are today? And what is one piece of advice you would give to someone starting out in similar shoes? Other than change the shoes, okay?
Let's start.
No, go ahead. Going first. I would. Ooh, sorry. I would say that the thing that helped me the most was that I took a lot of math very early on. In particular, I also think that tutoring helped a lot, because you can take a full sequence of calculus as well as differential equations and linear algebra. You can take all those courses. You can even get A's in them. But I still think that even if you excel, you won't fully appreciate or understand it until you actually sit down and try to teach it to someone else. And that's also part of the reason why at JPL there's a lot of emphasis on mentoring people. And it's because it helps new people who are just learning these concepts, but it's also a way of solidifying and expanding your own knowledge. So I definitely think that even if you're taking the course, if you find that you're moving a lot faster than your peers, offer to tutor them, or even tutor people that are in classes that you've already taken, because it'll help you and it'll help you excel later on.
I'm going to say two things. First, I think one pitfall that I see with my peers who are also at community college, I think a common trap is kind of getting stuck and not knowing what to do next. So I think one important thing that I did that I thought was really effective is to plan exactly what my path was going to be, like figure out what classes I need to take, which ones I already have, like write it all out, give yourself a plan, and then execute that plan. You never want to feel like you're kind of just floundering, you don't know what classes to take. I mean, obviously it's okay to experiment and explore, but like have an end goal in sight, whether that's transferring or getting your degree. Yeah, just don't get lost. Another piece of advice is I would say really get to know your professors. Here at PCC, like you have some of the best professors in the world, small class sizes. It's pretty easy to just get to know them as people, and those connections are super, super important and will almost definitely benefit you down the line. But even after you transfer to another school, sometimes it's more intimidating to talk to professors when you're in a class of like, 60 people, 300 people, like 500 people. But there is also where you really want to make that same effort, even though it's more difficult. If I had one thing I wanted to change about my time after PCC, it'd probably be that, is making better connections with my professors afterwards. So, yeah.
So I think for me, like one of the big things was like having a mentor. So here at PCC, like how they were mentioning earlier, I think it's very important to go to your professor's office hours. Some of you are very inclined to like not going because you're scared or you're embarrassed, but I think this is a good opportunity because professors have been in your position before. They can give you really good advice and they can really like help you and push you to be better. Sometimes I think we kind of need that. And I also think that we, just believing in yourself. I think that, being a STEM student, it can be very intimidating because you're like, oh, I have to do calculus, 5A, 5B, 5C, the physics sequence. And we go into these classes maybe, thinking that we're going to be defeated. But if you go in there thinking like, I'm going to be okay, I'm going to be all right, and, I'm going to go to tutoring and have like a study group, I think the outcome is better. And I think, honestly, it's just a mental game. Now, if you're, just starting now as a science major, I would also encourage you to get involved in a project. So maybe join like the engineering club or, some project where you can get some hands-on experience. Because I was also part of the engineering club, and a lot of the folks that were on the engineering club, I see them at work, I see them at JPL, and these kind of extracurricular activities really help you to discover what is it that you really want. And that's something that's really hard to answer because you can spend some years trying to figure that out. But the sooner you get involved, the sooner you'll realize what is it you want. And then you just, like Emily mentioned, you just make a roadmap of what is it that you're going to do. And I've done that as well for my master's, and I've just followed that, and it's helped me a lot. So I would encourage you to do the same.
I wish I would have went first because they said everything that I can think of. I would just say, other than, faculty, there's also lots of staff on this campus as well that are here to help you and really want to see you succeed. And, if you think that you're bugging them, then you're not doing it right. You need to make sure that they want to pull their hair out when they see you. It's never happened. Everyone wants to see you come. So just go to any person on this campus. If they don't want to help you, then they have the wrong job because we're all here for you. So make sure that you utilize that. Also, I would, the only thing that I would add is there's a lot of, fallacies that are in the air about college. Math. I'm not good at math. I think that's BS. Everyone is good at math. I'm not ready for college. You're always ready. I mean, if you're not ready, get yourself ready. You can always. It took me 15 years to get ready. I didn't start school until I was 33 years old. College isn't for everyone. That's a dang lie. College is for everyone. College is it's for everyone. If you could stop believing all those fallacies in the air, there's so many. PCC is 13th grade. I don't know if you ever heard that one. No, it's not. It's all a lie. PCC is not a real college. Community college is not a real college. That's a damn lie. The best education I've had was here. The most challenge I had was here. I went to Cal Poly and I breezed through that like nothing. It was nothing to me. But PCC, it was hardcore here. The graduate program was even easier, I would say. So make sure you do well here. You're going to get the best education that you get here. And so just take advantage of it. You have professors that are like amazing here. I've never experienced any other professors like that. So just make sure you utilize your resources because there's a lot of resources here. And if you don't, know where the resources are, I'll give you the first place to go. It's building LL 138. That's my office, and I will help you. All right. Oh, sorry.
So math is hard. I'm not good at math. That's why I'm going to school for it, to get better at it. I think one thing I can add to what everybody said that really helped me out is to follow my curiosity. You know, like there was always like work deliverables, you know, pressure to deliver projects, or at school, exams, studying. There's all of that stuff that has to be done just to kind of build up skill and strength. But for me, there were always other things on the side that I was curious about. And for me, that takes the form of like various side projects. I have open source projects. I have this, you know, piece of code that I've been working on for 20 years that like draws graphics based on like MIDI input, and it's, you know, it's held together with duct tape. But I still use it every once in a while, and it's awesome. But it took me a while to be able to kind of make space in my life and in my mental time to realize that there were these like sparks of ideas or things that I was interested on. And then to have the awareness that those are there, and then take the courage to be like, well, you know, I'm going to take some time and go write that thing or run that experiment, do whatever to bring those things to life. That's been a game changer for me.
Sir?
Yeah, I can share one personal experience in my teaching, because I am a chemistry PhD, so I teach general chemistry in UCR for like 2 years already. So I always told them, if you can do well in the beginning, try your best to do well, because you don't know anything is going to happen. Because in UCR, the chemistry series start from Chem 1A, 1B, 1C, and A8 and A8B. So I TA most of the time 1A, 1B, and 1C, and to me, those are very fundamental chemistry courses. And I still see that a lot of people don't pay attention to those lower division classes, and they just like spend their time doing nothing in the lab, and end up when they enter the senior or junior and senior level, they realize their GPA affected, because in Chem 1A, 1B, 1C, there's a 5 units course. And because the 5 units, if you got B, your GPA is going to drop a lot. So my advice to people is, if you can do well at the beginning, don't waste your time to work hard in the future, right? Because you have to have a very strong foundations so that you can move in a steady way. So I always tell them, if you can do well at the beginning, so your life in the future will be easier. Otherwise, you will spend a lot of time catch up. Just like me, before I transfer, I thought my GPA is good enough to transfer to the UCLA, but when I applied PhD program, my GPA was not pretty, actually. It's because I did not do well at the beginning. So if I would suggest, just try your best to do well at the beginning, because at the beginning it's always easy, and then you will build up a lot of questions when you start to have a higher level of educations. So, yeah.
Okay,
Thanks.
thank you. There's going to be some cards being passed out right now for those who want to ask questions. If you would mind writing your question down on them. And Dr. Chang Ho is somewhere here. I can't see. I should have worn my sunglasses in here. Okay, one more trivia question before we move on. Okay, why was the computer first made?
To get to the other side?
What's that? No. I mean, there's actually a valid reason for why the computer was first made.
Cryptography?
What's that?
Cryptography?
Yes. The very first computer was made by Alan Turing to crack the Enigma machine. And now another little bit of trivia. Why is a software issue called a bug?
Wasn't it because there was an actual bug?
Yeah, there was.
It was like an actual bug, right? Or
What's that?
wasn't it because there was like an actual bug?
It was actually a moth.
Oh, not.
It was actually a moth, and the phrase was coined by Rear Admiral Grace Hopper
Nice.
when this moth got vaporized on a vacuum tube and shorted out the whole computer.
Wow.
Okay, now, do you remember a specific experience where you wished you had done something differently? If you were to do it over, what would you do to change things?
I think I can start over from my side.
I know what I did.
Why don't we start from that side?
Okay, I can start from my side.
The ladies want you to start.
Yeah. I can. Well, if I can start over, I probably will take 55 and 10 for math. Because now I know that the differential equation and linear algebra is so important in my program, in my research. And my PI pushed me to learn those and know how to program. So if I can retake, I probably will continue for my math series in math department in PCC.
Similar answer. I would have taken a better linear algebra course. I kind of transferred schools, and I took the sort of off-season one, and I bombed it. And linear algebra is really, really important.
I'm just gonna have to say to you, PCC has the best math program, and Professor Hogue teaches linear algebra like a boss. So,
Yeah, I would take time too.
what I would have done differently is, like I said, once I decided to go to computer science from music, I didn't touch an instrument for 7 years. And, I realized that, yeah, it's possible to have two passions. So I wish I didn't, because now I tried to play my guitar, and it's kind of like I never played guitar before. Another thing that I regret not doing, I have two more, and I'm going to be really fast. I said this to some of you already, but I pretty much slept through my stats class because I was like, this is dumb. This is just to get through, just because it's a requirement. And it was the only math that I actually had to use in grad school, so don't sleep on your stats class. And then the last thing that I regret is I didn't take advantage of doing internships. So, I was told that lie, and this is a lie that you're probably hearing, that these companies say, oh, we want people who are juniors or seniors or about to graduate. They think that's what they want, right? That's what they think they want. Don't let that, I can't even think what I'm saying. Don't let that discourage you. Apply anyways. I mean, when I was here, I was applying for scholarships. They would say they wanted an Asian woman, in her teens. I was like, yep, that sounds like me. Sure. I applied for him, and I got him. So don't let any of that discourage you. They think they want 2 years, but what they really want is someone who's competent, and PCC makes those people. So just do it, please.
Yeah, for me, I wouldn't change anything. I was here for 7 years, and that's as long as some people take to do a PhD, I wouldn't change it, because I feel that those 7 years really taught me about what is it I really want to do and what is it I want to do for the rest of my life. And that's something that people kind of live a lifetime, can never get to that point. And yeah, I mean, I failed calculus. I was taking Ms. Hogue's class, and I failed it. And, I was doing the math path, 5A, 5B. She was like, I wanted to sit into the second, half of the class, and she was like, no, you got to study 5A. And I was like, nah, I got to stay in here. So I was like working as a math tutor, crashing her class, crashing Socrates' class. And yeah, I don't regret anything.
I totally agree with you about stats. I haven't taken stats since my last year of high school, where I took the AP test and I passed it. And then after that, I didn't touch it for all of college, and now I work in data science, so definitely wish I had paid better attention. Another thing is I wish that I'd taken more specialized classes. So I think, especially if you're thinking about computer science, it seems kind of there's generic computer science, and you can just get your degree in computer science. But there's a lot of different fields within computer science that, as someone in industry, you don't really get to explore unless you get into like a very specific type of job. There's things like security, things like graphics and video game development, even data science. So many different specializations you can take, and usually at a four-year college, once you transfer, they have classes and electives that you can take at a high level for those kinds of disciplines, and it's one of the only places where you can really explore those. After you get into the real world, you just get a job, and then you have to specialize in that one thing. So yeah, if I could do it over and I had more time, I would take more of those classes.
Just like everyone else, I also wish that I spent more time on stats. I hope that you're seeing a pattern here now. It really is probably one of the most important courses you'll take. You use it so much later on, especially in computer science. You can use statistics to kind of evaluate how well your algorithms are working. I'm actually doing my master's in machine learning, and about probably 90% of the write-ups we have to do to evaluate our trained models is just statistics, and I feel like I'm spending more time just revisiting statistics topics than the actual machine learning topics. So definitely focus heavily on stats, and don't let that, there's certain math topics you can let atrophy. Stats is not one of them. And also linear algebra. Linear algebra is the ultimate secret tool in mathematics. On a more personal note, one regret I have is that when I was in elementary school, I actually didn't do that well in math at all, and my parents were told, it's just not her thing, and I think that, you should have her focus on other subjects instead. Then I got to middle school, and I was placed in the lowest level math, but I was doing fine. I mean, I was getting the highest grades in the class, and I'll never forget when my math teacher asked me, there's still time, we could move you up a level now, and I thought about it, and I said, no, I really think that this is just a fluke. Now, after, once I got to high school and I'm still getting 100 averages in math, at this point I moved up a level, and then I was breaking the curve on exams. I finally said, okay, maybe they were wrong. But my regret is that I let other people define my own abilities, and you should not let that happen, especially when it comes to math. I think that most of the struggles that we have with mathematics is just society kind of defaulting to, math is just that difficult subject, it's just not your thing. And like Dave was saying before, that's not true. And anyone can do mathematics if you just put the time and effort into it. So don't give up.
Okay, thank you. Another bit of trivia before I start bringing people up. An Irish brewery named Guinness created a form of mathematics. What form of mathematics did they create? Or they are credited with creating a form of mathematics?
No clue.
A hint, it was to ensure that each barrel had the same amount of stout in it. Any takers? Okay, it is used worldwide by every brewery to this day.
Nope.
Three of you wish you took more courses in it. Statistics. Yeah. Yeah, so there should be motivation for a lot of people to learn stat, right? It was invented by a brewery. Seriously, look it up. It's very, very intriguing where math, certain areas come out of it. And now, who would like to, let's see, starting with the first row here, does anybody have any questions they would like? Oh, go ahead, sir.
Hi. I actually have two questions. One's really quick. The first question is dealing with Math 10. You guys all seem to be very adamant and excited about the us taking it as well as its importance in your work. Do you recommend taking it with Socrates? Like,
Yes.
yeah, yes, I
All
assumed
day.
I assumed you were going to say that.
Hogue.
But he's only teaching right now during the winter and the summer. So I don't know is that a good idea in your opinion?
I'm Team Hogue.
Team Hope.
Socrates.
Okay.
Team Hogue.
Okay, fair enough. And then the other question I have is actually for the JPL employee. I'm not sure what your name is. I'm sorry.
I'm sorry?
What's your name?
Yeah.
Danielle. So it's for Danielle. So I was curious, you mentioned you used a lot of math where you were calculating the trajectory and velocity for InSight. What sort of challenges did you face on InSight's approach to Mars?
Okay. So I should clarify that I did not work directly on InSight. I was just using that as an example. But I do know some of the challenges they did encounter because I work very closely with the people who did work on InSight. And one of the challenges is figuring out basically the best place for to land on Mars, right? We pretty much have to use tons of mathematical models to kind of come up with an estimate of the safest and most optimal place that the spacecraft can land. But even that is only within a certain tolerance. So it's kind of like you have to envision you have this target and you have to decide, okay, this is our current target. Here's the accuracy of actually landing within that target. Is this an acceptable tolerance? And I know that I think a few days before InSight landed, they recalculated their updated target, and they were like, oh no, this needs to be better. This needs to be better. And so they scrambled around and they worked all night to get a better approximation. And thankfully, everything worked out. But it is not easy. And the people at JPL, they work, day and night to ensure that everything is going to go right.
Next individual? Yeah, go ahead. Please use.
First, I'd like to thank every panelist for your very inspirational stories to share with us. I specifically have a question for Kingsley. What kind of, because you mentioned your research, so I'm curious about what kind of math you use for solving those equations, because you mentioned several equations. That's the first question. And the second one is, do you think the math preparation or training you had really helped you to solve those equations? Thank you.
Sure. Okay, so the math equations that I use, all the terms come from the force field, which is we define in chemistry. But pretty much those equations that you saw are based on the differential equations. And we also use some of this integration by parts and to incorporate in the force field. And in terms of solving those equations, we have a different strategy by using the statistical mechanics. That's even, to me, it's an even higher level in terms of math. So it's a combination of math and physics and chemistry. So yeah, I would say those mathematical equations come from a basic differential equation and integration by parts. And what was the question again? Sorry.
Do you think the mathematical training you had before really helped you to solve those equations?
Oh yeah, definitely. Because in chemistry program in UCR, you have to take 1 year courses, and those courses are required for you to further solidate your education background. So in those courses, like I said, the statistical mechanics, that's, I would say, is the most hardest class in the world as far as I knew. It's a lot of equations, and it's a combination of different equations and linear algebra and different integration by parts. A lot of combinations with that. So you do have to have a very strong mathematic background to solve that question and to do the research. And not only that, those are the first part, are generate the data. But in terms of, and the second part is how are you going to solve the data analyze data. You're going to have a lot of statistical background, bioinformatic background, and I did not mention that something that some mathematical skill that we use, what we call principal component analysis. There's something you have to really go into detail and to see how they apply in your research. So indeed, math background is very it's a required thing that in my research, and I still have to strengthen. That's why I said if I would not, if I would retake if I have a chance, I would definitely retake the differential equation and the linear algebra to kind of get it. So yeah, for me, that's very important in my research, for sure.
Sure. Is there anyone else who would like to ask a question? No? Okay, then the last, oops, I'm sorry, I can't see with the light. I'm blinded by the light.
So I just wanted to ask, why do you think there's not as many women in STEM, and what we could do to help with that?
Well, my PI is a woman. Yeah, my professor is a woman. So she's very good at math. So I don't think there's a reason that there's too many women in the field. Indeed, so as long as you stand out, like you definitely can do well. It's not about men or women.
I think you're totally right. Most women do not have anything keeping them from being into STEM if they are. But there is the reality is that most STEM programs have far more men than women, right? And we have to look at that on a structural level and ask ourselves why, and I think that's what you're getting at, right? Yeah, so like as you mentioned earlier, I think there's a lot of structural, I guess, biases and things that happen to women from very young as they get older. Like every step of the way, there are small stumbling blocks or big stumbling blocks that can keep you from getting into STEM. And some of those things, I think those are difficult to overcome. It definitely isn't something that just happens there's no one cause, right? It's not that employers are sexist. Well, sometimes they are, but it's not only that. It's not that girls aren't good at math. It's not that, or only that parents don't encourage girls to go into math. It's like a combination of a lot of those things. And as a woman in a STEM career, I think it's important to remember there's this thing called the mantle effect, where when you are the only person of some kind of external minority in a group, you're kind of expected to represent that entire group, whether you like it or not. And so for women, when you're the only woman at a meeting, when you're the only woman at a table, you're kind of expected to represent all women or, all whatever minority that you are. And that can be a really high pressure. It's why a lot of women leave STEM careers after a while, because you're kind of always expected to perform, and if you don't, there's this weight of not only your own failure, but feeling like you're responsible for your entire group of people. And I will say that, as a woman or any other minority, you will always stand out in your career, and there are ways you can use that to your advantage. But for the most part, it's just important to keep in mind that mantle effect. It's on a day-to-day basis. It can be pretty. It's just something you have to always keep in mind.
And can I ask if you guys are part of any women in STEM groups or?
So PCC has a group called She Codes that was started, I think, when I was here, and it's been doing really well. At a lot of big companies, for example, at Microsoft, we had a Women at Microsoft group who would meet and bring in speakers who are women, send people to conferences like a Grace Hopper conference, and those things are really helpful.
When I was attending my community college in New York. For 2 years in a row, I participated in, they called it the Math and Science Fair, Matters Fair, but it was specifically geared towards getting young women more involved in STEM at a younger age. And that to me is one of the it's a great approach to getting more women into all STEM fields, especially computer science. I believe right now computer science is still has the worst gender ratio. It's even, yeah, it's actually, I think it's actually worse than engineering. But the great thing about doing those outreach programs is I think that just by giving more exposure to these topics at a younger age and making, you know, young girls aware that, hey, these are things that you can do, I think that that's one way to really help improve the existing numbers. In addition, when I was at Cal Poly Pomona, we did also have our own She Codes club. Instead of getting involved in that club, I became the president of our Computer Science Society because I noted that there were no women on the e-board except for one girl who was also the president of She Codes, but she didn't hold a prominent role. And so I actually ended up becoming the interim president of that club, and then I used that to collaborate more with She Codes to kind of get more of an involvement and also try to get just more women coming to the general Computer Science Society meetings as well.
Yeah, I want to add is, like I said, my professor is a woman, and then she encouraged her students, I'm not woman, by the way. So she encouraged her students, especially one of my senior lab mates who graduates from the lab, and to apply a lot of women fundings, not only UCR, but a lot of symposiums where you can represent your research and apply a lot of awards only for women. And one of the things I can think of is in a chemistry symposium, like the American Chemistry Society, there's a specific symposium just for women. So there's a lot of opportunities and a lot of research opportunities for women and awards for women. So there's no like 50-50, or there's not a very strict line that stems only for men and not for women. So that's what I would add. So just explore more, then you will find more.
Can I add one thing? I'm not a woman, so I can't speak for women, but I am an African American male, and I can speak for African Americans, and because we have the same problem in STEM as well. And I think you know, one of the major problems that I see is that you know, I think it starts even at the institution. There's not enough diversity in our faculty, and that's kind of clean across all institutions. And I think once we can fix that problem, then we'll have students who will lean towards taking those courses because they can relate to the leadership. And it's really hard to be in the classroom where you can't relate to any of the leadership and they can't relate to you. So I think that's a big issue as well that's causing the gaps.
Thank you.
Any others? And how did you know my last, oh, I'm sorry.
I guess my question is, like, in terms of the whole passion thing, like, personally I'm into music too, but I have trouble balancing, like, computer science and music, you know, it's like two kind of completely different things. So what advice would you have in terms of, like, balancing that?
Can I?
Yes.
Yeah, go for it.
I'm not sure those are that different. There are a lot of software companies that make music software, for example. I actually tried to switch my career in that direction after working on email for a long time. I tried to get a job in Berlin at Ableton, who makes a really popular program that a lot of electronic musicians use for live performance. That was awesome because I got to go to Berlin and I went to their offices and it was very cool, but they did not offer me the job. But, you know, I think computer science can intersect with with a lot of things. So, you know, I think maybe just try to find that, you know.
I think that, you know, it's important to try to balance, you know, your passion for music and your passion for computer science, but, you know, don't focus on those two passions because you have other passions as well. You know, think of all your passions as like children, and you know, don't let one be the youngest child and one be the middle child. You know, just if you can't find a way to relate computer science to music, you don't need to. Just pick up your instrument. You know, that's all I can say. Just pick it up.
Well, I listen music while I'm programming, so I don't know if that's the balance. Yeah, because if without music, I feel bored just typing the codes, you know. So it's not like 100% you have to focus on your programming or sacrifice your music time, but sometimes when you like you need to take a break. Music is one thing that can help you to release your pressure. So as long as you know what you're doing, what you need to do, and what you're finished, then you definitely can balance well between science and non-science stuff. Yeah.
I'll add that I think it's really awesome to have creative hobbies and something you like to do outside of work. And one thing that I think is unspoken, but unfortunately true, is that with a lot of creative hobbies like music or art, many people who are successful in it come from a place of privilege. They have the financial background and the support to be able to pursue something like that. And with computer science, there's something we said for having a stable career where you can build up, you know, accrue that stability you need, and then in the future, in other parts of your life, or you know, as a career change in the future, pursue something else. Like that's always a path that's open to you. Nothing says you have to do what you're going to major in for the rest of your life. Yeah.
One thing I'll say, you know, it's good to have internships each summer, but if you unfortunately don't have an internship one summer, you could instead spend it working on a side project that has to do with music. So you kind of combine and find that intersection and then turn it into a side project. And employers like to see side projects in addition to internships. And so that is another way to kind of balance your interests, is to just combine them together.
Thank you.
Okay, now, I don't know how she knew that my last, as far as trivia question, was going to be on women in STEM. It must be psychic. But anyways, okay, it is true that the United States has the worst track record right now for as far as women in STEM, and in particular in computer science. Right now, nationwide, we're running about 10 to 20% female to 80 to 90% male in each graduating class. Other countries like Singapore are 50-50, and most of the European Union's between 30 and 40%. That was not always the case. During the late 70s to mid 80s, it was almost 50-50 as far as the percentage goes for computer science. Why?
I recall reading some article that said that women started using computers before men did, and it was more, I can't remember why though, but computers were more designed to help women for something. That's all I got for you.
We got two reasons. One is the Department of Defense did a big push to bring more people into as far as computer science and mathematics because of the Cold War. They couldn't staff enough positions, so they just funded everything, okay? And number two is the GUI, which everybody loves right now, was designed for women. Because it was thought, and this is not my opinion, okay? I don't want to get shot. It was, the command line was in use. In fact, it was made, Xerox was the one that made the first GUI in 1964, and they shelved it because it was useless to an engineer because doing everything on the keyboard. But Apple with the Apple Lisa, brought it out in order to bring more women into using computers in school. And it was the Apple Lisa that started the whole thing because it was more, and due to the sexist nature of the time, it was easier.
I just have to say, I just attempted to teach a room full of males command line, and they were looking at me like I was from another planet. Just had to bet
Use a subatomic energy as the next a renewable energy source. Is there a feasible method of harnessing subatomic energy as the next renewable energy source?
It's above my pay grade. I think that's out of our area of expertise.
I was wondering, my question is there a feasible method of using subatomic energy as the next renewable energy source?
I can't answer that question. I can tell you questions about data structures.
Is there a feasible method for using subatomic energy as the next renewable energy source?
I think that's out of our scope.
Yeah.
No, we understand the question.
You stumped us.
No one here is a physicist, I think.
No.
Anyone in the audience able to answer that question?
Professor Liu?
You stumped us. I'm curious to hear your opinion about that.
Oh, so my younger brothers had internships at JPL.
Cool.
Now, I graduated from John Muir's Airfield ROTC in 1997. So I was wondering, is there a way to use any feasible method to harness subatomic power as the next renewable energy source for the North America?
Yeah, I think that's out of the scope of our expertise. So, but a good question, yeah.
That would be a question for the physicists down in the Science Village or the Department of Energy. No one here is as far as in that area.
Okay, thank you.
Thank you.
Yay. If anybody would like to come on up and talk, everybody's going to be here for a while, correct? And one thing I will admit, the only things that I remember from chemistry are things that I should mix together to blow things up or things that I shouldn't mix together in order to kill myself. That's all I remember.
Yeah,
from
that
chemistry.
happened a lot in my lab. So I always told them, don't make things explosive, okay? And then protect yourself wearing goggles and lab coats because you don't know what's going to happen for those kids.
Thank you all for coming, and I sure hope you enjoy the rest of your day.
There's one more
Thank you.
question. There's one more question.
Sorry, just real quick, what suggestions would you have for people who wanted to teach themselves to code?
I would say go to codeacademy.com, go to YouTube, Udacity. Are you a PCC student? No? Oh, I was going to say come to my office. You still can. I'll give you my card afterwards. I'm always willing to help people learn. But I mean, you can Google. Like I told you, I learned how to make that little tiny button on my page by Googling code. So
That's okay.
there's lots of resources. Stack Overflow is a really good one.
There's also like a MIT Open course. So whichever kind of language you want to learn, you can just go and then, see the material, the courses, the videos.
Okay.
You can also see videos on YouTube, depending on what kind of language you want to learn. But I've seen a couple videos there on Python, because that's what I use. But yeah, there's also apps and stuff like that you can do.
Yeah, I definitely recommend some kind of intro course. There's a lot of kind of CS fundamentals that you'll learn when you first start learning computer science. They might seem a little bit theoretical and you're like, I don't know how I'm supposed to use this. I just want to build a website at first. But if you just keep with it, like it'll make sense in the end.
Yes. Oh, sorry.
I also recommend using Reddit,
Hell yeah.
especially you can check out CS Career Questions. That's a really good subreddit. And you can also check out the newer CS Majors subreddit. I moderate that sub. So, yeah, either of those subs are really good for either industry and major specific information, but they're also good for just finding good learning resources as well.
Yes. Oh, yes,
Okay. Hello. Just a little background about me. I attended PCC from 2014 to 2017, and I'm currently a senior at Cal Poly Pomona, and about to graduate this semester. So I have just a question for you. What was your attitude towards finding, let's say, your first job for like the uncertainty in kickstarting your career? Do you have any advice for like a proper attitude or how to approach things?
Well, for me, since I had an internship, I think that really helped me out as well because, I got to work in a group and I got to get trained. So my boss basically just asked me if I wanted to stay. So that was, that was a good way to get the job. But I would encourage you to kind of already start applying, send your resumes out. What was your major again?
Computer science.
Computer science?
Yeah.
Maybe they would have better options, better answers for you about computer science, because I'm double E.
Definitely, you want to start applying at the beginning of your senior year and just keep applying that whole time, because otherwise what will happen is you'll graduate, and if you haven't been applying, then now you're going to spend possibly a few months applying when really you could have been doing that while you were in school. So definitely start applying as early as possible, and also try to get an internship, even if it's just one. Because if you get even just one internship and you do a great job, then you can safely assume that you have one offer already lined up. And even if even if it's not that crazy, like that great of a company, you don't have to start out at your dream company. Just any kind of work experience is good, and then you can always move later on as you go. Especially for computer science, you should also start practicing interview questions. I recommend Cracking the Coding Interview by Gail Ackman McDowell.
It's my backpack.
Yeah, I would also say, does your school also have like a career fair or something, or like HENOC conference as well?
We did have a career fair, I think, last week.
Cool. Yeah, I was also going to say definitely go to career fairs. It's one thing to apply online, like, it's in the same portal that everybody applies to. It's a totally different thing to meet a recruiter or an engineer and like build up a relationship with them, even just over like 5-minute talk and like have them put in a good word for you. It's completely night and day. Another thing, since you're a senior in computer science, definitely start grinding that LEET code. Another website, so Cracking the Coding Interview is a classic and definitely good. A website that I really liked, so I just left my job at Microsoft, so I had to like redo the whole interview thing again. A website that I really like is called Pramp, PRAMP.com. It's so you can set up some time, like schedule an appointment with another person who's looking for a job, and then they give you 2 questions on either side, and you teach the other person, you ask the other person the question, and then they ask you, so it's like a mock interview. But it's really awesome because it forces you to set up a time to do it instead of putting it off like I would. And it also, as people have said, like teaching someone to do something, you learn better doing that than just learning it yourself. So like some of the things I remember the most is the questions that I've asked other people through that process. So I highly recommend that. Yeah, computer science interview questions is like a very specific set of knowledge. It's really, you get what you put into it. Like just keep practicing and you'll get better and better.
I would say another thing to do is go to like websites like HackerRank. They're going to give you code challenges and practice. Get yourself a whiteboard and practice doing those on whiteboards, because every interview I went to, we didn't touch a computer. Kind of like our classrooms, right? We didn't touch a computer. And just make sure that you can actually write out these algorithms on the code. And probably, do you have a girlfriend?
No.
That's good. That's good. Do you have a crush? Do it in front of your crush. Do it in front of someone that you're like terrified of, because that's what it's gonna feel like. You're gonna it's going to be terrifying because you're on the spot. You have to write on a whiteboard, and people are going to try their best to make you cry. So practice that. And I agree with what Danielle said about taking, you may not get the one job that you want, but I also would have to say, don't just take any job either. When I got offered a job at a defense company, and they were like, ooh, 6 figures. I was like, sweet, about to freaking be a boss, right? But the entire time I was like, something just doesn't feel right. Something doesn't feel right. And I was about to accept a job where I just had this feeling that something didn't feel right. And I quit my job here. I told them, hey guys, I'm out of here. I'm like, in January, I'm out. But something didn't feel right. And so I just didn't go. So make sure that you feel right about it. You got to make sure you feel right about it.
Okay. Yeah. Right. I have an on-site interview next week, so I'm just nervous.
Yeah.
Good luck.
All right. Thank you so much.
I have a career in computer graphics and animation, and been very successful. I'm grateful with that. But it got to a point where I realized that I want to build some of the things that I create in there. So I decided to come back a few decades later to college to pursue a career on robotics. So I'm starting with math. But clearly it changed from some decades ago. So I want to have perhaps some advice from you guys on how does it work, because I'm not coming from high school, I'm coming from the real world back into here. So even Canvas is completely new to me.
I would say, like, since you're coming back from such a long time, maybe go to a lot of tutoring. Go to a lot of tutoring, right?
Okay.
Form like study groups. And if you want to start kind of like exploring robotics, maybe start using like Arduinos and learn like basic coding, just to have like a early start before you start taking your robotics classes. I know they offer robotics classes here.
Yeah, when I started in computer graphics, there was no graphical interface, so I had to learn Unix to use what was the precursor of Maya back then, Wavefront. So I did the basics, but I didn't have the thinking of it. I just knew how to do the things that I created.
Yeah.
So right now I'm coming back and I'm trying to figure out what are the essentials. I realize I need math, and so I'm going heavy on math. And I did my algebra, and I'm back on trigonometry, and there is a robotics class that I'm taking as well. But it's almost like looking forward. What will give me a good direction of what do I need to think outside those two that I need to look into?
I would also say, like, it depends what you want. Like, do you want to go for a bachelor's? PCC offers a AA in electrical engineering. So maybe think about what is it that you want to do, because maybe just by getting the AA, you can work somewhere. So just think about that.
As far as like general career advice, I would definitely recommend you talk to the computer science professors here. They've had to keep up with the industry just because they have to see new kids going into the industry every year, right? So they can definitely give you pointers as far as what you need to start applying to jobs, what interviews will ask you, that kind of stuff.
Cool.
Yeah.
Thank you.
Yeah.
Now, before we open up to everybody, as a small token of appreciation, we'd like to give each of you a plaque to remember us by. The plaques say essentially, presented to, and then your name, in grateful appreciation for your efforts in the student-led educational event, Pi Day Student Conference, which promotes the endless possibilities and contributions of mathematics. The Division of Mathematics and Computer Science, and the Pi Club, Pasadena City College, the Department of Mathematics, Cal State University, Los Angeles, May the 14th, 2019. Danielle. case there's a selfie, right?
Thank you. Thank you.
Thank you. Emily. Edward. Sorry. Dave.
This is fancy. Should put you to sleep.
Adam.
Because that's like the actual key
You're welcome.
Oh.
I made it.
You made it, okay.
It's fun.
Great, thank you.
You gotta market that. Sorry. Kingsley.
Thank you.
Go ahead.
Now we would like to invite all the attendants, all the students, and to come maybe together to the board, to the stage, and we can have a group picture with all the speakers. Yeah, that would be cool. Yeah, come.
Yeah, well, I'm waiting for everybody to get in.
What we're going to do is the people in the back.
That's why I'm staying over here, till everybody's in position.
Okay.
come forward.